Hi everyone and welcome to the Daily Maths Challenge number 6. We've got some trigonometry questions for you today. So let me continue to the questions. So starting with bronze, we're going to find the missing angle x in the shape below. Okay, so we've got two angles here that we know for sure. Okay, so we've got 75 and 70. So let me just write down my triangle here. Okay, so we have 75 degrees. That's this angle here, and 70 degrees here, and we're missing the angle x here. Okay, and we need to find out what x is. Now the trick with triangles is that no matter what your triangle looks like, no matter how big it is, no matter how big the angles are, all three of the angles are going to add up to 180 degrees every time. Okay, and this goes for every triangle ever, okay, on a flat surface. So let's say that, well, we know that 75 plus 70 plus x is going to be equal to 180. All right, so next what I'm going to do, just to make it a bit easier to see what's going on, sorry about that, I can add 75 to 70. That's going to give me 145, and that's going to equal to 180 when we add it to x. Okay, now to work this out, we're going to take away both sides. From both sides of the equation, we're going to take away 145. Okay, I'm leaving a lot of my working, I'm just doing it step by step, really, just to make it easy for you to see. And then if we take that away from that, I'm going to get 35, and then it's degrees, right? Degrees is the units we're using here. Okay, that looks good. Okay, so now moving on to the next one. So for the next one, it says find the missing angles in the shape below. Okay, so we have a triangle, 2x, x, and x are the angles, and x is the same in each expression. What this means is that this x here is the same x as the one here. I don't really have to put this line in normal maths questions. It's kind of like assume that in the same context, x is not going to be changing all the time unless it's like a different object, like a function or something like that. In this context, it would be clear that actually x is going to be the same one in each one. So how would we do this one? Well, let me draw my triangle. So I have x, x, and 2x. Now, I'm going to do this in two different ways. First way, we can notice that if we split this in half, if this angle is 2x, and clearly I've split this into two equal parts, actually, is this obvious? The way that I've drawn this, is it obvious? Is that a fact? Can you split these into two different ones? Not necessarily. You know what? Actually, I'm going to skip that one. I've kind of assumed a lot of another result. For example, this is. Can you see that this is a isosceles triangle, right? The angles are the same. So on that basis, if I do send a vertical down, so it's perpendicular, I am going to be splitting that angle in half. That's just a fact. That's just a fact. But it requires a bit more work. So actually, this isn't my favorite solution for you guys, because you have to take it on trust that actually that's a result we can use. Anyway, let's just progress with this result. So then we have this triangle here, and then x plus 90 plus x. Can you see we're adding all the angles in this triangle? That's going to equal 180. This right angle is 90 degrees, okay? So we have 90 plus 2x equals 180. Take away 90 from both sides, that's going to give you this. Divide by 2, 45 degrees, okay? Now, let's look at a different way of doing that. That wasn't my favorite way for you guys, because I used a result which you had to trust me was true. But we're actually going to just use the same fact we used last time for the bronze one to solve this, that the angles in the triangle add up to 180. So whatever x is, I'm sure you agree, if we get the number x and we add 2x and we add another x, we should get 180 degrees, because this is a triangle, as I said earlier. No matter what it is, it's going to add up to 180. So I have 1, 2, 3, 4 x's here that I've added together, okay? And now that's going to be 45 degrees. So, oh yeah, of course it's going to be the same one as before. I don't know why I actually worked that out in my head again. So x can be 45. We're going to divide both sides by 4, and we get x is 45 degrees. Just realised that you couldn't see that. Sorry. And that's that. So again, just summarizing, we just added all of them together. We knew that it had to be 180. We just simplified this into this is the same as 4x's. 1x and 2x and 1x together makes 4x. Obviously 4x is 4 times x. And then I divide both sides by 4. That's going to 180 divided by 4 is going to give you 45. And we're done. Now let's go quickly to the next one. So the next one states, okay, so we need to find out what is sine 30 degrees, okay? What is sine 30 degrees? Without using a calculator, but rather using the diagram below, where the big triangle, this triangle is an equilateral triangle, and the side is 1 unit long. I haven't included 1 centimeter or 1 meter. I haven't included a unit there, but that's okay. And you may leave your answer as a cert. Okay, I'm not going to go into what that is. That was just for those of you who knew what that was. But basically, this is how we do it. Now, we need to try and work out how we're going to use this equilateral triangle that has all sides equal being 1 unit long. How can we use this triangle here to help us? Well, this is a right angle degrees. I've just sent a vertical down. Okay, so it's been 90 degrees. I've split this triangle in half. And actually, we know that the angle in an equilateral triangle is 60 degrees. Each of these are the same, 60 degrees. But this angle's been split in half, so actually this is 30 degrees. Now, we wanted to find out sine 30 degrees. Now, it's a fact that if you have what we call a right angle triangle, okay, if this is the right angle, and the angle opposite this right angle, sorry, the length opposite this right angle is called the hypotenuse. Let's say that this is h. And then let's say that we're looking at an angle like this. Any of these angles I could have chosen as theta, but the idea is that when you're looking at a particular angle in this triangle now, either this one or this one, let's say we choose this to be theta, that defines, your choice of angle defines the opposite side, so O for opposite, and then the adjacent side, A for adjacent, and that's a fact. Whatever sine theta is, whatever we get if we put theta into this function sine, we should get out the opposite over the hypotenuse, okay? Whatever this length is divided by this is going to give you sine theta, okay? Now this could have worked for any triangle with an angle of theta like this, and no matter what these lengths were, it would have turned out that this divided by this is actually always the same. It's always sine 30 degrees. Sorry, sine theta degrees. Okay, so how does this help us here? Well, our triangle, let me just do another right angle here. Our right angle triangle is this one, okay? So let's take theta to be 30. What is sine 30 degrees? Well, sine 30 degrees, can you see, is the opposite side to the angle over the one that's opposite the 90 degrees, the hypotenuse. Well, the one opposite this 90 degrees is the 1. Okay, so that's on the bottom of the fraction. And the angle that is opposite this angle here, our theta, is a half. Can you see this was 1, but I've halved it to get this side. Okay, so it's going to be a half over 1. That's just going to be a half. Anything divided by 1 is itself. And that's it. Now let me just encourage you. Sine 30, I'm in degrees. If this was an R instead of a D, that was highlighted, we would be measuring angles in radians, which is a different, I can't even call it a unit. Technically it's dimensionless, angles are dimensionless, but that's just another way of counting angles. But sine 30, yeah, a half, okay? So that's how we do that one, okay? That was a nice and short episode. I hope you enjoyed it, and I look forward to seeing you hopefully in the next one. Okay, have a blessed day. Bye.